I thought I'd make a video so that we can go into our exercise 3C, which is the divisibility. We actually finished 3B back when we were at school in term 1. So we'll continue through exercise 3 and then we'll go from there. So exercise 3C is about divisibility. Divisibility is the noun for dividing, basically means to split something up, right? So we'll be going through two things this video. First off, we'll be going through key terms of divisibility, and then we'll be going through divisibility tests. Now, this is actually in your textbook, so if you turn to page 122, it'll be there. So let's start by key terms. So what does it mean for a number to be divisible? So divisible or divisibility. So let's write divisibility. Divisibility is when a number is divided by another with no remainder. No remainder. Awesome. So let's do an example, because that's just a bunch of words, right? Let's do an example. So let's say I have 27 divided by, let's say, 9. Well, we know that's the same as if I write 27 and a little skate ramp, 9. So 27, this number over here, that's what I call my dividend, right? It's a number that's being divided. So let's write dividend, which is our number. Let's move the screen. Number being divided. Awesome. So that's our original number. The number that we're dividing by, in this case, it's 9, right? We're dividing 27 by 9. We end up with, and that's my divisor. And that's the number we divide by. Because if I read 27 divided by 9, 9 is a divisor, and dividend is our 27. Awesome. So what's 27 divided by 9? Well, we know it's 3, right? So I write 3, and this 3 over here, that is my quotient. So these are all the key terms. Quotient. The key terms that you should be familiar with as we move on. So our quotient, number of times the divisor goes into dividend. So in this case, the number of times that 9 goes into 27. Pretty easy. Now let's do a different example. So once again, let's use the number 27. And I divide it by, let's say, 4 in this case. So how many times does 4 go into 27? Well, 4 goes into 27. We know that 4 times 6 is 24, right? So we know that it goes into 6 times. So I write 6 here. But there's a remainder. Now there's a remainder. So how do I get from 24 to 23? I add 3. So my remainder is 3. All right. So the same thing. So this is my quotient. My 6 is my quotient. I'm using the same colors so that we can identify them. That's my quotient. This is my dividend. Remember, dividend is the number that's being divided. I can't spell today. There we go. Dividend. This is my divisor. And finally, this is my remainder. My remainder is the number left over. Perfect. So we have our quotient, a divisor, a dividend, and our remainder. So those are our key terms when we're actually working with dividing numbers. Now, if it's divisible, now what does it mean to be divisible? Is when you divide the numbers and there's no remainder. So if I said, is 27 divisible by 9. So that's our first one. Well, yes. There's no remainder. Now, if I said, is 27 divisible by 4? Well, the answer would be no. There is a remainder of 3. So if there's no remainder, it actually becomes a factor. So because 27 divided by 9 gives you a whole number, like 3 with no remainder, that means that 3 is a, sorry, not 3, sorry, 9 is a factor of 27. So I'll just write it underneath, if I can move the screen here. If the divisor is divisible, sorry, if the divisor, let's start with the dividend actually, if the dividend is divisible by the divisor, it's like a tongue twister, then the divisor is a factor. So if, for example, I have 48 divided by 6, 6 being my divisor, remember? Oops. Divisor. Well, 6 goes perfectly into 48 8 times. So I know that, and there's no remainder. So I know that 6 is a factor of 48. Perfect. The last thing I'm going to go through is divisibility tests. Well, it's like a tongue twister. Feel free to pause this video whenever you want, just to make sure you can catch up. There's plenty of time. So our divisibility tests are over here. I'll move that over here so that we can see. Divisibility tests are over here. If, for example, I have a number like, let's pick a number like 2, 4, 6, 2, 7, 4, 7, 8, and I said, is that divisible by, actually, yeah, is that divisible by 5? Well, you might be able to tell me whether it is or not. You might go through and multiply 5, 10, 15, 20, blah, 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 all the way up to, what is this? 2,462,478. But that would be a waste of time. And honestly, I think you and I will both get really bored. So there's the divisibility test, which help us figure out whether it is divisible by 1 to 10 without actually having to go through and calculate the factors or the multiples, right? So let's start with 1. So 1's over here. Let's start with 1. All numbers are divisible by 1. That's true. All whole numbers, all integers are divisible by 1. Now let's go with a bit, one that's a little bit more difficult. The number 2. So let's say, actually, let's tick this so we know that this number over here is divisible by 1. Is it divisible by 2? So all even numbers are divisible by 2. The last digit must be 0, 2, 4, 6, or 8. In my case of this number here, 2,462,478, the last number is an 8. It's even, which means it is divisible by 2. So let's tick that. Number 3, oops, sorry. Number 3, the sum of the digits must be divisible by 3. So let's add them together, actually. Let's add them together. So 2 plus 4 gives me 6. 6 plus 6 gives me 12. I'm just going through these numbers, by the way. So it gives me 12. 12 plus 2 gives me 14. 14 plus 4 gives me, I should probably just do this in a column, actually. So 2 plus 4 is 6. Plus 6 gives me 12. Plus 2 gives me 14. Plus 4 gives me 18. Plus 7 gives me 25. Plus 8 gives me 33. Awesome. So the digits actually add up to 33. The sum of the digits must be divisible by 3. 33 is definitely a multiple of 3. 3 is a factor. It's divisible by 3. So this is also divisible by 3. Our number 2,462,478. Awesome. Let's keep going. So number 4, or for divising by 4, the number formed from the last 2 digits must be divisible by 4. So the number formed from the last 2 digits, in this case, the last 2 digits are 78. We have to figure out, is 78 divisible by 4? So 78 divided by 4. 4 goes into 7 once, so I write 1. There's 3 left over. 4 goes into 38 how many times? 4 goes into 9 times, and up with 36, right? So there's a remainder of 2. So no, this is not divisible by 4, which means that the whole number of 2,462,478 is not divisible by 4. So right across there. For number 5, the last digit must be 0 or 5. In this case, it's an 8, so it's not divisible by 5. It must pass the for 6, it must pass the divisibility test for 2 and 3. So did it pass 2? Yes. Did it pass 3? Perfect, which means it is divisible by 6. 7, there is no easy divisibility test for numeral 7. It's actually quite difficult. So that's one you're going to have to calculate very, very, very slowly. Let's keep going, go with 8. So let's put a question mark there. Let's go with 8. The number formed from the last 3 digits must be divisible by 8. So the last 3 digits, so 4, 7, 8. Let's try and divide that by 8. So 8 goes into 48 how many times? 5 times. End up with 40, so it's 7 remainder. So 8 goes into 78 how many times? 9 times. And that gives me 72, there's 6 remainder. So no, it does not divide into 8. The sum of the digits must be divisible by 9. So let's keep going. So let's add them again. So total, if I add the digits, I end up with 33, sorry. So the sum of the digits is 33. Can it be divided by 9? No, so I cross that out. And the last digit must be 0 in order to be divisible by 10. It's not. So I know that this number is divisible. Oops, that's not a D. Divisible by 1, 2, 3, 6, and that's it, 6. So that's all for exercise 3C. Let me know if you have any questions. Best of luck.